We're all told to be data-driven, but honestly, that usually means we jump straight to the complicated stuff like big data and fancy algorithms. That's like starting a race at the finish line. To really, truly master data, you gotta start with a simple but incredibly powerful framework for just classifying it. This is the secret foundation. It's how the best in the business turn a bunch of numbers into game-changing decisions. Okay, let's get into it. So here's how we're going to tackle this. First, we'll lay out the core framework. Then we're going to do a deep dive into each of the four scales: nominal, ordinal, interval, and ratio. You'll see how each one builds on the last. And finally, we'll tie it all together to answer the big question: how do you pick the right one for the job? It's a perfectly me-see approach, mutually exclusive, collectively exhaustive. The gold standard for thinking clearly. All right, before we get into any theory, let's imagine we're on a factory floor. A brand new TV is sitting in front of you. Your job? Check it for defects. But what does that even mean? How do you measure a defect? Do you just give it a thumbs up or a thumbs down? Do you rank it against all the other TVs made today? Or do you get out a tiny ruler and measure the exact size of a scratch? Each one of those choices gives you a totally different kind of data. This TV factory is going to be our guide through this whole thing. And the answer to that tricky factory problem is this beautiful framework: the scales of measurement. It's a system that sorts any piece of data into one of four buckets. Now, why is that so important? Because the bucket your data falls into dictates everything. It tells you what math you can do, what charts you can make, and what conclusions you can actually draw. Getting this wrong? It's like trying to measure how much water is in a glass with a ruler. You'll get a number, sure, but it'll be completely meaningless. So let's start at the very beginning of our framework. Level 1, the nominal scale. This is the absolute simplest form of data, but don't let that fool you. Sometimes, as we're about to see, the simplest data can be the most important. The word to focus on here is nominal. It comes from the Latin word for name, and that's all this scale does. It names things. It puts them into categories. Think of it like sorting laundry into piles: whites, darks, colors. There's no order, right? One pile isn't better or bigger than another. They're just different.
So here's what you can and can't do. The data is just categories. There's no logical order. You can't say that blue is somehow greater than red. And because of that, you can't do math on it. You can't calculate the average color, right? That makes no sense. What you can do, though, is count how many things are in each pile. And you can find the most common category, which in stats lingo is called the mode.
Okay, let's bring it back to our TV. Using a nominal scale, our quality check is a simple binary choice: pass or fail. Does it turn on? Yes or no? This gives you a high-level number, like a 98% pass rate. That's great for a manager's dashboard, but it gives the engineers zero information about why the other 2% failed. It's a scoreboard, not a playbook.
And in that question, the why is what brings us to level 2. A simple pass/fail just isn't enough to really improve things. We need more detail. We need some kind of ranking. So let's move up to the ordinal scale. Just like the name sounds, with the ordinal scale, the big upgrade is order. We're still putting things in categories, but now those categories have a logical sequence. We can say one thing is better than or bigger than another. But, and this is a huge but, the gaps between those ranks, they aren't necessarily equal. The difference between first and second place in a race could be tiny, while the difference between second and third could be huge. This makes the difference super clear. Nominal data, like colors, are just labels, but ordinal data, like temperature categories, cold, warm, hot, has a clear progression. You know hot is more than warm, but how much more? We have no idea. Think about a customer survey with ratings from poor to excellent. You know excellent is better than good, but is the jump from good to excellent the same size as the jump from poor to fair? Almost certainly not. That's why you can't really average this data. You find the middle value, the median. So, back on our factory floor, we could now create quality grades: grade A, grade B, grade C. Or just line up all the TVs from worst to best. Now this is way more useful. The engineering team can grab the 10 worst TVs and figure out what's going on. We have a priority list. But we still don't know if a grade C TV has 2 problems or 20. The gaps are still a mystery. To solve that mystery, to really understand how big our quality problems are, we have to level up again. We need a scale that doesn't just put things in order, but also measures the exact, consistent distance between them. Welcome to the interval scale. With the interval scale, we get another major upgrade. Now we have numbers where the difference, the interval, between them is always the same. The difference between 20 and 30 is the exact same as the difference between 70 and 80. This is huge because it means we can now do more math, like addition and subtraction, and we can calculate a meaningful average. But there's a really important catch. It doesn't have a true zero.
So what does no absolute zero actually mean? It means that a value of 0 on this scale doesn't mean the thing is gone. The classic example is temperature. 0 degrees Celsius isn't no heat. It's just the temperature where water freezes. It's a point on a scale. And because of this, you can't make ratio statements. You can't say 20 degrees Celsius is twice as hot as 10 degrees Celsius. If you don't believe me, just convert it to Fahrenheit. 10 degrees Celsius is 50 degrees F, and 20 degrees Celsius is 68 degrees F. 68 is definitely not double 50.
And that little problem brings us to the top of our framework, the highest, most powerful, and most flexible level of measurement, the scale that unlocks all of the math. This is the ratio scale. The ratio scale is the whole shebang. It has everything the interval scale has, order, equal gaps, but it adds the one missing piece, a true, absolute zero. On a ratio scale, a zero means a complete lack of that thing. Nothing, nada, zip. It is a real, absolute starting point. Let's really hammer this point home because it's the key to everything. Interval scale, 0 is just another number on the line. Ratio scale, 0 is the absolute end of the line. 0 kilograms means there is no weight. $0 means you have no money. And it's because of this absolute zero that we can finally make those ratio statements. We can say that 10 kilograms is twice as heavy as 5 kilograms. We can say $500,000 is $500,000. We can do it all: add, subtract, multiply, and divide.
So back at the TV factory, the ratio scale gives our team superpowers. We're not just sorting or ranking anymore. We can now measure the exact length of a scratch in millimeters. We can count the precise number of dead pixels on a screen. 0 millimeters means no scratch. 0 dead pixels, a perfect screen. This is the kind of super precise data you need for serious quality control, like Six Sigma. Now we can finally tell our engineers that the average scratch is 0.8 millimeters long, and we need to cut that in half. Okay, we've gone through all 4 scales, from simple labels all the way to absolute measurements, so now it's time to bring it all together. What's the so what here? How do you actually use this stuff to get things done?
This table right here, this is your ultimate cheat sheet. It lays out the whole framework. As you go down the table from nominal to ratio, our analytical power just grows and grows. Nominal tells you what kind, ordinal tells you the rank, interval tells you by how much, and ratio lets you say how many times more. The big takeaway here is you should always try to collect data at the highest scale you can. Why? Because you can always go down. You can turn a precise measurement into a simple ranking, but you can never go up. And that's exactly why serious methodologies like Six Sigma are built on ratio and interval data. If you really want to understand a process, to measure how much it varies, to see if it's capable of meeting your goals, you need data that you can do real math with. You just can't do that kind of deep analysis with ordinal rankings of good, better, and best. But here's the final crucial insight. This is what separates a good analyst from a great one. While the ratio scale might be the most powerful mathematically, it is not always the most important. Context is everything. Imagine you've built the perfect car. The engine is flawless, measured with ratio data. The gas mileage is best in class, also ratio data. But the customer ordered a blue car, and you deliver a red one. That is a total failure. And that critical piece of data, color, comes from the simplest scale of all, nominal. So the ultimate takeaway is this. This whole framework, nominal, ordinal, interval, and ratio, it's not just some academic thing. It's a strategic tool. The right scale isn't determined by what's mathematically best. It's determined by the problem you're trying to solve. So the question I'll leave you with is this. As you look at the data that drives your work and your decisions, are you consciously, deliberately choosing the right scale for the job? Because that choice right there is the foundation of every single great data-driven decision.